Good morning. So it's the last day of our fourth week. So we have a week left after this. So I'm just going to go through our work real quick. Well, not real quick, but so I'm going to share the screen here with you. It's not in a PDF. Oh, I guess you're seeing the whole screen. All right, that doesn't matter. So today we're going to look at parallel and perpendicular lines and then equations of lines given slope and point. So today is the last lesson of this unit, and then on Monday, instead of a test, you guys are going to have a assignment. So I'm going to go through this with you here. So when we talk about parallel lines, that means that they're following each other right beside. So where one goes, the other one goes, and they never cross at all. So you can almost think of it as like train tracks. So the two tracks of the train track are always following each other, but will never touch each other. Whereas perpendicular, they're going to cross each other like this or any kind of way. So it's different than parallel because parallel never touches one another, whereas perpendicular has to for it to be perpendicular. So like I said, there are two lines that never cross each other. The distance between the lines stay the same. So one's not like they're always going to be straight beside each other. One's not going to go kind of further because at some point that will touch at the bottom a little bit. So if we look at the first one, we're going to name this one line number 1. Okay, so we want to look at the slope of this one. So what we're going to do is we're going to take our 2 points like we've done in the past. So you take your 2 points and you're going to calculate your rise over your run. So your rise will be 1, 2, 3, 4, 5, and 6. So it'll be 6 over, and our run is 1, 2, 3. So it'll be 6 over 3, which can be simplified to 2. Okay. Our y-intercept is where it crosses the y-axis. So right here. So we have our point right here, which is our y-intercept. So that'll be 1, 2, 3, 4, 5, 6. So it'll be 0.6. Okay. And like we've learned in the past, we put it into our equation. So y is equal to our slope, which is 2 times x plus our x or y-intercept, sorry, which is 6. And then we're going to look at the second line here. So this is our number 2. Okay, and we're going to do the same thing. So we're going to take 2 points and we're going to calculate the rise. So 1, 2, 3, 4, 5, 6. And then our run will be 1, 2, 3, which can be simplified again to 2. 6 divided by 3 is 2. And then our y-intercept, so we're going to look at our y-axis and it crosses here, and that is -2. So we're going to put it into our equation. So we're going to take our slope, which is 2 times x, and then our y-intercept, which is -2, so -2. Okay, so what do we notice about the two lines? So the two lines both have the same slope. They might not have the same y-intercept because they're crossing over the y-axis at a different area, but they are moving at the exact same rate. So the rate of change is the same thing for both of the lines. So the slopes are the same, so both slopes are 2. However, the y-intercepts are different. So line 1 y-intercept is 6, whereas y-intercept for line 2 is -2. Okay, so the beautiful thing about parallel lines is the slope's going to be the same. The only thing that's changing is the y-intercept because it's being placed at a different part on the graph. So I'm going to clear this and we're going to look at a second one. Okay, so here we have write two equations that are parallel to the line y equals 3x plus 1. So like we just seen, our parallel lines have the exact same slope. So both of our new equations are going to have 3x in it. The only thing that's going to change is that plus or minus at the end. So 3x. So we're just going to pick a random number here. So I'm going to do plus 6. Okay. And same thing for the second equation. So the second equation is going to be 3x because the slope cannot change. The slope has to be the exact same for the parallel line. So don't go making it like 6 or anything. It has to stay at 3. Okay, and we're going to put that one as a negative, so -2. So what I'm going to do is I'm going to do this one as red on the graph. This one is orange on the graph. And we'll do this one as blue on the graph. Okay. So when you are drawing your lines on your graph, you're going to start off with your y-intercept. So we had learned this yesterday. So you're going to put your y-intercept at -2. I'm starting with the blue just because my pen's already blue. So our y-intercept for this equation is -2. And then that means we've got our slope of 3. So that's with a rise of 3 and a run of 1, because there's that little invisible 1 that's here, right? So we're going to go up 3. So 1, 2, 3. And we're going to go over 1. And you're going to make your point. You're going to do the same thing again. So 1, 2, 3, and over 1. And you're able to make your line after that. So I'm going to see if I can. It's a little bit trickier on the computer than it is with a ruler on paper. So there's our first line. And then we're going to look at the orange one. So we're going to do the same thing. So we're going to put our y-intercept. So our y-intercept is 6. So 1, 2, 3, 4, 5, 6. Okay, and that's going to go up by 3. We're actually going to go the opposite way because we can't really with this one. So we're going to go down 3, 1, 2, 3, and over 1 right there, down 3 over 1, and we're going to make our line, which apparently is already a line, and that makes sense why my points wouldn't work. Okay. So we can already tell it's parallel. So they're following each other. They're at the exact same distance the whole time, and they never cross over. Now we're going to do our original equation. So our intercept here is 1. So we're going to start at 1. And then we're going to do our slope. So we're going to go 1, 2, 3, 1. 1, 2, 3, 1. And you make your line. If I can do this properly. Well, that definitely could have been better. Okay, so you can see here, if I would have done that middle line a little bit better, they would have been the same distance. They would have been following each other through the graph. So I'm going to clear this and we're going to look at perpendicular lines. So like I said, perpendicular lines are two lines that intersect or cross each other at a 90-degree angle. So that means it's going to make a perfect T of some sort, or X. No, T is the better one. So we're going to look at the first line here. So I'm going to switch back to black. So our first line is here. Okay, so we're going to look at the slope of this one. So we're going to get 2 points that are easy to calculate. So let's do this one. I guess to here. Okay, so our rise is going to be 1, 2, 3, 4, 5, 6, 7, 8. 8. And then over. So 1, 2, 3, 4. So it'll be 8 over 2. So 8 divided by 2 is going, oh no, this is supposed to be 4. Oh goodness. So 4, So 8 divided by 4 is going to give us 2. And then we're going to look at where the y-intercept crosses the y-axis. So we're at 1, 2, 3, 4, 5, 6, 7, 8. So it crosses at point 8. And if we put that into an equation, so y is equal to our slope, which is 2 times x, and then plus our y-intercept, which is 8. And we're going to look at number 2 here, so line number 2. And we're going to do the same thing. So we're going to take this point and this point. And we're going to look at our rise. So our rise is 1, 2, 3, 4. And because it is going downwards, it's going to be negative. So negative 4 over, and then 1, 2, 3, 4, 5, 6, 7, 8. 8. And we can simplify that, so it'll be negative 1 over 2. And we're going to look where our y-intercept is, so where it crosses the y-axis. So in this case, it's 1, 2, 3, 4. And we're going to put that into an equation. So like we've seen many times before, it's y equals our slope, which is negative 1 over 2 x, and then plus our y-intercept, which is 4. Okay, so what do we notice about the slopes? So they're not the same. If they were the same, that means that they would be parallel. So in this case, what it is it's the negative reciprocal. So you're taking this is on a fraction, right? So 2 is over 1, like any other number. Okay, so what you're going to do is you're going to flip those two numbers and you're going to make it negative. So if we see here, this is 2 over 1. So for it to be perpendicular, it's going to be negative 1 over 2. So you're flipping your fraction, you're making it negative. Okay, so I'm going to clear this. We're going to look at the next question. Okay, so the first one, so find the negative reciprocal for negative 3x plus 2. So I need the drawing. So the negative reciprocal for negative 3, sorry, is going to be positive 1 over 3. So because it's already negative, it turns into a positive. So you're just switching the sign over and you're flipping that fraction. So if we look at this one, this is going to be negative because it's already positive. So we're doing the opposite. And then you're going to switch these guys. So it's going to be negative 4 over 3. This one is technically over 1. So we're going to have negative 1 over 4. Okay, this one's negative 1 over 2. So it's going to use the opposite sign, and it's just going to be 2. This one here, same as the 4, is over an invisible 1, and it's positive. So to do the opposite, so the reciprocal, it's negative 1 over 8. And this one is negative, so we're going to have it positive, and it's 6, so it's technically over 1. So we're going to have 1 over 6. Okay, so they want us to write an equation that is perpendicular to this guy here. So we found that the reciprocal to negative 3 is 1 over 3x. And you can pick whichever y-intercept you want. It doesn't matter. So we're going to do plus 4, for example. Okay, so I'm going to do our original one in orange. And then I will do our new one in green. Okay, so like we've done in the past, you do your y-intercept. So we're going to do our y-intercept here. And it's going to be negative. So we're going this way. So negative 1, negative like this. So rise is 3 and run is 1. So like that. Okay, get enough points that you're able to make a line with. So there's our first equation, our original equation. And then we're going to do the same thing in green. So our y-intercept is 4 here. Oh, it's doing a line instead of a point. Okay. Okay, so you're going to do your dot at the y-intercept. And this is going to go up 1 over 3. So up 1 over 3. Okay, we'll do down 1 over 3 just to add here. Okay, our line could be a little bit better, but it is what it is. And as you can see, this angle here is 90 degrees. So that's how you know that it is properly perpendicular to one another. It's not parallel, it's not following each other at the same distance, it is crossing each other at a 90-degree angle. Okay, so I'm going to clear this. So now your independent questions, you've got to make 3 parallel lines and graph them. And then you have to do 4 perpendicular lines and graph them and answer the questions. Okay. I hope that makes sense, and I will post the second video shortly.